Okay, now we're going to begin our discussion on complex waves. So all of the waves we've spoken about so far have been sinusoidal, simple harmonic, pure tone waves. But the sine wave is not the type of vibratory motion that we experience in our everyday lives. It's not super important for speech, but it was very important for us to understand a sine wave because it's the fundamental component of all of our complex waves of speech. If you look at A, that's our sine wave. That's our pure tone, simple wave that we've discussed. B, C, and D are complex waves, which are better reflections of the vibratory motion of the vocal folds. Fourier's theorem, a complex wave is characterized as any sound wave that is not sinusoidal, any sound wave that's not a simple pure tone. A complex wave is composed of a series of simple sinusoids that differ in amplitude, frequency, and phase. So a complex wave is a bunch of sinusoidal or simple pure tone waves that are added together. When two or more sine waves that differ in amplitude, frequency, or phase are added together, we get our complex waves. The degree of complexity depends on the number of sine waves that were added together and their dimensions, their amplitude, their frequency, and their phase. This theorem was first stated by Joseph Fourier, and that's why it's called Fourier's theorem. He was a mathematician at the time of Napoleon. So a series of sine waves that are combined to compose a complex wave is called a Fourier series. Remember, we have our simple pure tone waves. When they get added together, they become a complex wave. A complex wave consists of some number of sinusoids that differ in amplitude, frequency, and phase, and the nature of the complex wave can be understood if we look at the dimensions, the amplitude, the frequency, and the phase of the sine waves that built that complex wave. So we can take a complex wave and do Fourier analysis and pull out the sine waves that compose that complex wave. We can analyze or decompose the complex wave by looking at the amplitude, the frequency, and the phase of the sinusoids that compose it. All sound waves can be classified according to whether or not they are periodic, whether or not they repeat themselves, and how complex they are.